Every night, above our heads, the universe continues to change. Millions of stars are born, shine, and disappear. But some, before dying, leave behind something that defies all imagination. A place where gravity is so intense that it bends space and time. A place from which not even light can escape. We call it a black hole. For decades, these objects were considered almost science fiction. Today, we know they truly exist. We have observed, photographed, and studied them. Yet, the most important question still remains unanswered. What is really inside a black hole? To find out, we must go back billions of years. It all starts with a star. Not just any star, but a giant much larger than our sun. For millions of years, nuclear fusion inside its core produces energy, counteracting the force of gravity in a perfect balance. But nothing lasts forever. When the fuel runs out, the pressure supporting the star disappears, and in just a few moments, gravity takes over. The entire star collapses in on itself at unimaginable speeds. The resulting explosion is a supernova, one of the most powerful events in the universe. If the remaining core is massive enough, it continues to compress more and more until it creates a region of space where gravity becomes practically inescapable. Thus, a black hole is born. Contrary to what many movies show, it is not a massive vortex that sucks everything in. If the sun were replaced by a black hole of the exact same mass, Earth would continue to orbit in the exact same way as it does today. The difference is that we would no longer receive light or heat. A black hole does not pull any harder than other objects. It is simply an incredibly compact object. But there is a boundary that completely changes the rules. Scientists call it the event horizon. It is the point of no return, beyond which not even a photon, the particle that carries light, can escape. And it is precisely here that the true mystery begins. Imagine being aboard a spaceship heading toward a black hole. At first, you wouldn't notice anything unusual. The stars would keep shining, and space would seem as silent as ever. But the closer you get, the more things begin to change. Gravity grows stronger and stronger, and according to Einstein's theory of relativity, time begins to slow down. For you, everything feels normal. Your watch keeps ticking, and your heart beats at the same pace. But for someone watching you from far away, something incredible happens. Your every movement becomes slower and slower, and each second seems to last an eternity, until, from their perspective, you appear to freeze right at the event horizon, and then vanish. This phenomenon is called time dilation, and it was predicted by general relativity. But time is not the only thing that changes. Space also begins to warp. If the black hole were not supermassive, the difference in gravity between your head and your feet would become immense. Your feet would be pulled much more strongly than your head, and your body would begin to stretch out more and more. Scientists have given a rather curious name to this phenomenon: spaghettification, because any object would be stretched into a very long filament. Fortunately, in supermassive black holes, like the one at the center of the Milky Way, you could even cross the event horizon without noticing anything immediately. And this is where one of the most fascinating questions in physics arises. What happens next? Einstein's equations describe a singularity, a point where density, gravity, and the curvature of space-time become practically infinite. But many physicists think this is not the final answer. Something else might exist. A structure we do not yet understand. A new physics capable of uniting relativity with quantum mechanics. In 2019, for the first time in history, humanity managed to photograph a black hole. The image traveled all around the world. That blurry orange ring is not the black hole itself. It is the light of superheated gas rotating at incredible speeds around the event horizon. At the center, that completely dark region is its shadow, a direct proof that these objects truly exist. 3 years later, astronomers managed to capture another image. This time, it was of the giant black hole at the center of our own galaxy, Sagittarius A star, an object with a mass equal to over 4 million suns. Yet, despite these achievements, the mystery remains. What happens to information when something enters a black hole? Does it disappear forever, or is it somehow preserved? It is one of the most important problems in modern physics. In recent years, some scientists have proposed new ideas. According to some hypotheses, the singularity might not exist at all. Others think that quantum gravity prevents matter from compressing infinitely. For now, there is no definitive answer, and it is precisely this uncertainty that makes black holes so fascinating. Every new observation, every new telescope,
And every new mission could completely change our understanding of the universe.